Is the voice clear? Fully audible? Charging is on. Okay, no problem. Charging on. Fully audible? Okay. We'll start now. See, I'll just give yesterday's question. See, last class example. Everything is over. Little concept is there. See, last class example, little extra portion. See, everything is over. Our final part. See, this is the footing plan. I don't remember exactly now. This is 4.1 meter. This is your L1. Your L2 is how much? 3 point. How much it is? L2. How much L2? L1 is 4.1. L2. How much L2? How much L2 last time? L1 4.1. What is the L2 value? I think 3 point something it is. How much L2 value? See, L1 over. What is L2 value? See, again you are not giving answer. You are not giving answer. I can hear my voice, everything is clear. See, if you don't reply, same problem for live class. If there is no reply here, how I can remember yesterday's values? L1 I remember, 4.1. Column also I remember. See, the column I will put here now. The column dimension, this is 0.23, this is 0.75. How much L2 equal to? How much? Yesterday we finished the class. What is L2 value? 3.6 meter. Okay. Now, see, you reinforcement you got, finally, see, this is lengthwise steel. This is, I show from here, widthwise steel. You look from this side, see. This is lengthwise steel, that is 16 torr, I remember, at 120 center to center. This is 16 torr at 150 center to center. That means if you write this, just show one bar sufficient. That means actual arrangement of steel is, I will put here now, you show one bar. See, this how, and the slab thickness you are right here, slab thickness is 750 thick. And drawing you should write not 4.1 meter, final drawing you are write 4100, and here you are write 3600. Column dimension write 230 by 750. Okay, that's okay, no problem. Not a big issue. Now, if I take lengthwise cut, see here, you can see column here. This is how the arrangement for lengthwise. If I take widthwise cut, this way, you can see smaller column side, this way. Now, lengthwise bar is like this. This is your 16 torr at 120. See, this is the steel. Widthwise steel is like this. This is your widthwise steel, this one. Now, what you have to do is one small concept. See, this is cantilever bending like this. This is cantilever bending like this. Here, this is cantilever bending like this, cantilever bending like this. When you put the bar here, see, for this bar, this section, and for this bar, this section, these are points of what? These are points of what, tell me? For this side, this point, for this side, this point, these are points of maximum BM. BM for lengthwise bending. And this point and this point, they are points of maximum BM for widthwise bending. Widthwise bending. Correct? Yes or no? Till fast. Clear? See, maximum BM here. This is the points. These are the points of, see, maximum for this side, maximum BM here. For this cantilever, maximum BM here. That way. These are the points of maximum BM. Now, what you have to do is, C1. Here, we got to, see, we got both critical. Now, condition is that, see, now if I consider only one side cantilever, see this bar, only this bar, up to here. Only up to here. I'll put a dark one now. Small concept, see, I'll make it dark color. That bar comes like this, see. This is the point of maximum BM. Here, if I show only one side bar, remember, later in ETABS class I will not tell. This here. This is a bar. See, here, maximum bending moment. This is the point where bar will have maximum tension. This is the point where bar will have maximum tension. Now, what you have to do is, the rule is that from here, bar should not be stopped. Actually, you are not stopping. As per code, this should extend this side. See, this side. This bar should extend this side. See, right correctly. So, this extension should be minimum. How much? Tell me. That extension should be minimum how much? Tell the answer. That extension, you should not stop the, actually we are not stopping the bar. What happens is, this bar should extend further by what? You know that principle. I told earlier in RCC class and ETABS class, from here, it should extend further by how much? First. What it is called? You cannot stop the bar here. You have to actually you are extending. You should extend by what distance? Tell me. The bar should extend further by what distance? You know that one. Those who came to RCC or ETABS class earlier, I told it. I told very clearly. Extend by what? If you are not knowing this one, what is RCC you are doing? I told very clearly. They should extend by a length not less than what it is called. They should, the bar should extend, see, same way. This bar should extend this side. This bar should extend this side. That bar from here should extend this side by a distance minimum LD. Okay. Here also minimum LD. LD means development length. See, development length LD equal to 5 into sigma s divided by 4 times tau BD. Okay, start. I will not explain much now. Why? Already explained for you earlier RCC classes. Anybody new for this one? It is your problem. I cannot tell these things now. So equal to M25 concrete, FE 500 steel. This LD equal to 5 is diameter 16. Sigma s is 0.87 into 500 divided by 4 divided by, tell me, M25 concrete as per IS code, tell what is tau BD. First answer. First. See IS code. Go for development length. There, table number, everything told for you. If you don't answer, I am helpless. This RCC class so much explained. Tell me, some table number. I don't know what a table number. In the IS code, development length formula is there. Next page, one table is there. In the table, they are given limit state method for M25 concrete. What is tau BD? Answer. First. First answer. What is tau BD? You have to give the answer. Don't delay unnecessarily. Open the IS code. Go to development length. I don't know the page number. I don't have code here. If code is there, I would have seen the code and written. My IS code copy, I placed somewhere. It is misplaced. So anyway, if I don't know where I kept it. It is misplaced here. Oh, 1.4. If wrong, I am not responsible. It is 1.4 Newton per mm square. Not 1.4 into 1.6. Tell y into 1.6. Tell me. Y into 1.6. Full explained in ETABS class. ETABS class and RCC class thoroughly explained. Why 1.6? Tell me. 1.4 is as per IS code. Then into 1.6. Why? Reason. Why it is 1.6? No, why it is 1.6? Increased by 60%. Tell the answer. Tell me what is the answer. First. 16 into 0.87 into 500 divided by 4 divided by 1.4 divided by 1.6 is 776.79 millimeter. Okay, 776.8 millimeter. Therefore, remember, now I will remove all this one now. See, I will tell you should write. This bar should extend from here, this side, by minimum of 776.8. Same way, see, this bar, I want to put one, same way, see, this bar, you write one more sketch, should extend this side by a minimum of 776.8. This bar from here should extend this side for a minimum of 776.8 because both are 16 torr. Same way, this bar should extend that side by minimum of 768.8. Minimum. You can extend more. Now tell me, what is the actual extension available? Actual extension available. Tell me here now, correctly answer. See here. If I take this part, actual extension available here is how much? Tell me. What is the projection here? Tell me. What is the projection here? This column side is 750. Okay. So what is this distance? 1 point. What is the lengthwise projection? What is lengthwise projection? 1 point. Lengthwise projection, how much? 1.675. This is 1.675 meter. So actual extension available for lengthwise bending is 1.675 meter is 1675 millimeter plus column side 750. Column side 750. See why? Because from here, when this is a bending, it should come this side. See, you can make out. When you bend this way, it will pull the bar this way. To balance by bond, to prevent it from slipping, you need available length is 750 plus 1675, but minus some clear cover. How much clear cover? Minus 50 clear cover. Okay, answer. How much is the available length? Actually, you can tell up to center of bar you have to take. That's all you can ignore. No problem. That's all you can ignore. Somebody will comment, no, you have to take up to center of bar. Ignore those things. Don't tell those things all. I will take up to here. How much number? 2375. 2375 is the available, which is more than LD required of how much? 776.8. Therefore, okay or not okay? The bar should extend for at least around 776.8, but available extension is 2375 for this bar this side, for this bar that side. So okay or not? Therefore okay. Okay, now same way. See, for widthwise bending, available extension is, tell me what is this projection? Tell me what is this projection, or what is the projection here? Widthwise projection. I'll put here now. What is the widthwise projection? 1 point. Widthwise projection, 1 point. What is widthwise projection? 1.685. 1.685 meters. So it is 1685 plus this column side is 230 minus 50 clear cover. Answer. How much? 50 clear cover. Answer. That is the available extension on widthwise. 1865, which is more than requirement of 776.8 requirement. Therefore, okay, even widthwise also. So, development length is satisfied. Now, make a note. In case not satisfied, what to do? Here, happily satisfied. See, very happily satisfied. What to do? What to do is make a note. Usually, practically, this will be satisfied. For isolated footing, it will be satisfied. Remember, this you have to worry, detailing part. See, now, if not satisfied, what you have to do is, this bar, you provide a turn here. See, this way. Provide a 90-degree bend. And this side bar, see here, 90-degree bend. Write one more sketch, this way. When you provide a 90-degree bend, then you got this much extra extension. Yes or no? That much extra extension. Tell yes or no? You got that much extra extension. If it is not satisfied, that much you get extra extension. Correct? If it is not satisfied. Yes. And also one more thing. When you provide a 90-degree bend, that 90-degree bend itself is equivalent to an extra extension of 8 times diameter. Why? It is called anchorage value of 90-degree bend. Because when 90-degree bend is there, bar becomes, it is difficult to pull the bar. The 90-degree bend itself gives imaginary extension of 8. So, if I take up to here, you get extra of 8 times diameter and this length. Usually, then it will be satisfied. Suppose by chance, still not satisfied. No, it won't happen. Then, further extend inside. Again, one more 90-degree bend. Again, 8 times diameter plus extra. That way, check it. Now, actually, I have this theory, it is given IS code, all are following. But I don't agree because when this bar is in tension, you should go for the difference of the tension. Therefore, development length required becomes much less. Somebody who knows subject may tell, actually see double cantilever, actually development length is not required if both are equal overhang and equal bending moment. No development length required. I know it, but nobody follows that one. That means, see, when this is bending that way, if this bar is pulled that way, see, when this is pulling here, this will pull this side. See, it will pull this side. Therefore, that it will mutually balance. So, that be on safer side, but usually nobody will do. Someone should not tell, oh, this person does not know that concept. I know that concept, but I don't tell because why? People don't follow. What they do? They see that the extension available is LD. If not there, they go for extra turn and maintain it. Make a note. Now second note. See, same question, second note. These all remember in the ETABS&SAFE class, when you decide footing, I will not tell. I will tell, remember all those things. Make a note. Now, when you go for the final sketch here, see, one more note. This is the footing. See, plan. See, this is 4.1 meter in our case, L1. This is 3.6 meter L2. L2 is 3.6 meter. What IS code will tell you is, in case of rectangle, square footing, no problem. If rectangular footing, IS code has one more suggestion. Make a note. That is, it is given in the IS code. I don't have here. So yesterday, I asked someone to send it to me. So I will read it now. Okay. It is in the WhatsApp only. Who has sent yesterday? yesterday, one nimisha, it's here. Geo. Yes, see. In two-way reinforced page number, IS code, page number is not visible here because in the photo, page number 65. It is only for rectangle footing. Page number 65, IS code. Make a note, see. It is 34.3.1 C. 34.3.1 C. They told in case of two-way reinforced rectangular footing, the reinforcement in the longer direction shall be distributed uniformly across the full width of the footing. Reinforcement in our column is somewhere here. See, somewhere here. They are telling reinforcement in the longer direction. That is today's class question this way. See, should be reinforcement in the longer direction shall be distributed uniformly across the full width. See, this is the uniform distribution of longer direction. No restriction. Full width means whatever steel you got. See, if you remember, it is 12 torr in the longer direction. That is lengthwise bending. 12 torr at 120 center. Reinforcement in the longer direction. Then, if you see in the shorter direction, what they think is, see, this is 4.1, 3.6. See, now, see the reinforcement in the shorter direction. For reinforcement in the short direction, a central band. Now, this is for reinforcement in longer direction. Longer direction. Then, come one more sketch here. See, one more sketch. This is the reinforcement in shorter direction. They told, don't spread it uniformly up to here because when you come to this extreme end here, see somewhere here, if you place a bar, it will not be effective. Why? See, this bending is okay. This bending, when you take this bending, see, as the projection becomes more and more here, this bending becomes lesser. So they told, for reinforcement in the shorter, you have to mark a central band. Central band. This is the central band. Central band. Reinforcement in the short direction, a central band equal to width of footing. Means what? For, tell me, the central band equal to width of footing. Tell me. When you see this way, tell width of footing how much? Not 4.1. Other way, how much? Okay, now I have to once again go to chart section. Tell the answer. Tell the answer. Width of footing. For this bending, what is the width of footing? Width of footing. For this bending, tell me, what is the width of footing? 3.6 meter. So, therefore, tell the offset here. Tell the offset here. From 4.1, subtract 3.6, divide by 2. Answer. See, a central band of width equal to width of the footing. What is the offset? This is 4.1, this is 3.6, these two offset. 0.25 meter. Okay. Actually, it is very small. 0.25. So, what they are telling now is, see, once again IS code. For reinforcement in the shorter direction, a central band equal to width of footing shall be marked along the length of the footing and portion of the reinforcement determined in accordance with the equation given below shall be uniformly distributed across the central band. Means, see, you have to place the reinforcement here. How much steel? See, how much steel? I tell how much steel here. See, if you remember, you already know okay. Now, this is the steel for lengthwise or widthwise bending. Tell me, This is steel for lengthwise or widthwise bending. This is a steel for lengthwise or widthwise bending. And again go for YouTube now. See, that's the problem because IS code is not there. This is the steel for lengthwise or widthwise bending. This is for widthwise. Tell me, for widthwise bending, tell what is the AST required first. Tell what is the AST required. For widthwise bending, tell what is the AST required first. What is the AST required for widthwise bending? You know the answer yesterday. See, yesterday for widthwise bending, you know the AST required. After design for shear, see, after checking for shear, finally we increase the steel for widthwise bending. Tell the answer. AST required for widthwise bending. Yesterday. No, not spacing. AST required. AST required for widthwise bending. Spacing came later. AST required for widthwise bending. I will briefly tell it. This footing, it is not required first of all. I will tell you later. Tell the area required. What is the area of steel required for widthwise bending? What is the area of steel required for widthwise bending? 1333. 1333. They are telling, see, they are telling how much steel? It is 1333. Total, see, this is the total AST required, AST for widthwise bending. A part of that one should be given here. Major portion, how much? See, 1333, I will tell you. I'll go to YouTube, not YouTube, I will go to WhatsApp once again. Now, they told one formula, see here, one formula. The formula is reinforcement in central bandwidth divided by total reinforcement. They told in shorter direction. In shorter reinforcement means here in shorter direction. That is here widthwise bending. That one should be equal to 2 divided by beta plus 1, where beta is ratio of longer side to shorter side of the footing. Shorter side of the footing. Tell the answer. 4.1 by 3.6. What is the answer? 4.1 by 3.6. 4.1 by 3.6. What is the answer? Now, okay, sufficient for me. Just make a note. 4.1 by 3.6. What is the answer? That is beta. 1.1388. Therefore, you get what? Reinforcement, therefore, reinforcement in central bandwidth, central band divided by total steel is 1333 should be equal to 2 divided by how much? 1.1388 plus 1. Therefore, tell me what is the AST in central band? What is the AST in central band? Calculate. 2 divided by this number into 1333. 2 divided by that number into 1333. Answer. 2 divided by that number into 1333. Answer. I will briefly tell here and stop. This is you learn later yourself. Or further more details I will give in the ETABS class later. Because I am going beyond this here now. 1246.5. 1246.5. Therefore, they are telling, see, this steel lengthwise, no problem. Uniformly distribute. Widthwise steel, they told this steel should be how much? Should be 1246.5. Tell me the remaining steel here. Tell what is the remaining? Remaining steel. Among of 1333, 1246.5 should be here. Remaining should be how much? Remaining 1333 minus 1246.5 divided by 2. 1333 minus 1246.5 divided by 2. Remaining steel, how much? Very small. How much? Remaining. Divided by 2 by either side. 1333 minus 43.2 mm, 43.2 mm square. 43.2 here and 43.2 here. Distribute. Now, 160 mm bar area is 201 mm square. Ayyo. Then what is this one? Tell me. 160 mm diameter bar area is how much? Area is 201. And one more thing. See. Clear cover of 50 mm is there. So if you leave clear cover 50 mm, if it is 250, this will become 200 millimeter. Do you think anybody for such a small length of 200 go for this calculation? Tell me. Anybody will go for this calculation? For a full footing is there, they will tell end portion, this small length, little change the steel. Anybody will do it? Tell me. Anybody will do it? Nobody will do it. But they will do it in, I will tell you next example. I will tell you. If such these cases, you should tell what is this. See, 2 divided by 1, tell me 2 divided by 1.1388 plus 1. Tell the number. Tell what is number. Tell what is number. 2 divided by 1.1388 plus 1. What is that number? 2 divided by 1.1388 plus 1. What is that number? Point. What is that number? Point. 2 divided by 1.1388 plus 1. What is that number? Point 935. That is 93.5%. They are telling this whatever steel you require here, 93.5% steel should be here, and remaining how much? 93.5 means remaining what? 93.5% means remaining how much? Remaining 6.5%. That is divided by 2. 3.25% on either side, you have to change it. Some will tell that much variation, not required. People will not bother. So first of all, practically they will not bother. If someone will ask, they will put one extra bar and tell, get out now. I will not change. If you are that much eager, take one extra bar. So therefore, for this footing, this provision, you need not bother, but you have to bother. I will tell you little later now. When you have to bother, that when it comes to of the total 100%, nearly 94% here, 3% there means what is this? See, therefore, for our question, that provision you need not consider. So our final drawing, which will go to site, is what? See, 4100, 3600. Column is dotted line. Why? You cannot see column. Okay, right? 230 by 750. Show one bar this way. Sufficient. Right? 16 tor at 120 center. Center not required. One bar this way. That is not one bar. This is 16 tor at 150 center. And somewhere here, the plan, you are right. 750 thick. This is a drawing which is going to the site. Clear now? This is a drawing which is going to the site. Actually not required. Suppose you do a lengthwise cut. What you can see drawing? If I do a lengthwise cut, see, I can see one bar here. That's all. That is 16 tor at 120. Then these bars I can see by dots. That is 16 tor at 150 center to center. This drawing is not required. To the site only this drawing will go. Sections all nobody gives. And if I take a widthwise cut here, see, you can see like this. If I take a widthwise cut, I forgot here, thickness is 750, thickness 750, rough sketch. Okay. Become too rough actually. Okay. You can see one bar here. This is 16 torque at 150 and other bar, you see here, you can see here, this bar is below. So dot you can see here. This is your 16 torque at 120, this is 150, and of course column bars are, you can show the column bars also. This is a sketch you will get for a site. First of all, these sketches are not given practically, only plan given. Clear? First. Clear or not? That provision I will tell you. Such a small distance, nobody bothers. If somebody argues, he will put one extra bar there and tell keep quiet. Full clear? Because I will give briefly one example for you, then go to combined footing. Okay, now we have to go to combined footing. Remember, see in the link I have written combined footing, but before that one example required. This I told you earlier, briefly I will give you, very briefly. It will be almost homework for you. Remember, workout. See, I will tell you why it is required. See, for a, I let question here now, for a column of cross section, say 200 millimeter by 600 millimeter, or I will take a little more. I will go for 200 mm by 800 mm, little bigger column, 8 mm. Design isolated footing for all working loads. Nobody should ask. Axial load of, one nimisha. Axial load of 1250 kilonewton, and see, or I'll do one thing now. 1250 along with column. If I write this way, you know the meaning. If I write this way, you know the meaning. I already told you. One moment this way, say clockwise. Okay, this time I'll do one thing now. Okay, clockwise will do. Clockwise of lengthwise, this way lengthwise of 200 kilonewton meter and widthwise of 140 kilonewton meter. And SBC of soil is, little problem is there for soil, only 175 kilonewton per meter square. And remember, take M25 plus FE500, same steel. But remember, condition, there is a condition. Condition is that this is the column. See, when you provide footing, there is a boundary line here. See, from center of the column, this distance is restricted. It happens so many times. Remember, the restriction can come lengthwise also. Restricted to means not more than. Restricted to. Why restriction means reason. Maybe another footing comes here, or boundary problem is there. So one restriction. If double side restriction comes, then you have problem. That all you solve in ETABS&SAFE. Why? Manually there is a limit. Restricted to. I will tell you later. Some meter. I will tell this question later, I will tell. Because I want to know what size is required. Time being one thing. Restricted to some meter. It is not some meter. I am going to tell you later. Instead of wasting time setting, calculating it, let it come. Okay. I will do it brief solution. As soon as I feel that this question will join the previous question, I will stop this question. This question will join the previous question. Then my work will be over. See, start. Solution. Briefly solution. Area required. You can use Excel sheet, remember. For this one, you can use Excel sheet, but no, leave it now. Excel use later. Area required. 1.1 into P. What is P? 1250 divided by 175. Not explaining 1 micromillimeter. Why? What? Do you think I have no other time? No other work to do? Everything is told for you. How much area required? Answer. Area required in plan. Answer. If anybody tells, not clear means leave the class and go and take rest. So much explained earlier, including preparation of Excel sheet. Now if you ask, what is this formula means, leave the class. 7.857. 7 point, remember, I am giving only brief solution. Only brief solution. 7.857. Remember, 7.857 is only for axial load. What is the problem? There is additional pressure due to moment. So, increase by, tell a percentage. Last time, if you remember, first time when I made a trial, I increased by what percentage? Tell me last time. Last time when I explained the question, first I tried how much percent more for for additional pressure. If you remember, how much percent more I tried. This you can use Excel. 15%. I feel personally that 15% is not sufficient. Or okay, I feel 20% is better. I feel. Okay. That is, area is approximately, answer, increase by 20%, answer. Increase by 20%, answer. I will tell you what is happening here. This is practically happened so many times. ETABS&SAFE model, I will not explain later. This one. Why 25%? Okay, 25%. Okay, done. Someone told 25%. Answer. Okay, good. 9.428. 9.428 equal to L1 into L2. Now, one sketch here. Actually use Excel. See. This is 0.2. This is 0.8. This is your L2. This is your L1. Now, equate the projections. What do you get? This projection equate. After writing all the story, you write L1 minus 0.8 divided by 2 equal to L2 minus 0.2 divided by 2. Clear or not? Clear or not? Not this way. Those who are serious write every story. The L1, L2 are decided so that projections are equal, lengthwise projection equal so and so, widthwise is so and so. You write all that correctly and do it. Correct? You write clearly, or I'll do one thing now. Okay. You write statement all. This should be clear. Or 2 will cancel. L1 minus what? Minus 0.8 minus 2 is minus 0.6 minus L2 equal to 0. But you know that L1 into L2 equal to 9.428. So your L2 equal to 9.428 by L1. Substitute L1 minus 0.6 minus 9.428 by L1 is 0. Multiply by L1, you get L1 square minus 0.6 L1 minus 9.428 equal to 0. Tell the value of L1 required fast, and therefore tell L2 required. Fast answer. I will tell you why I give this question, not for fun. L1 required. Solve the quadratic equation. This already solved earlier. This already solved 9. Now I can't do anything. 9. Someone told 9.428. Now I cannot agree. Sorry, too late. Too late. Now I won't agree. Then why you told 9.428? No, sorry. you should have be careful. When it is 9.42, where is the answer? When it is 7.857, I told increase by 1.25%, 9.821 it becomes, or 7.857 into 1.2 is 9.428. Okay, 20% only. Okay, 20 only. Done. Now I can't change. These mistakes if you make, I cannot repair. See, there is a limit for what? Kannadadalli, Sahare anta. Okay, leave it. Now 20% only. Tell the answer. L1. No, now 9.428 only. Sorry. Now because you should have told me earlier 9.821. One size you told 9.428. Now you are telling. Okay, leave it. Okay, no problem. 20%. Okay, 20%. 3.385 meter. 3.385 meter. L2 required. Calculate. 9.428 by L1. L2 required. L2 required. 9.428 by L1. L2 required. I will tell you why this question I am giving, not for fun. I may solve little more because practically important. My class is for ETABS&SAFE, that is for those who are learning structural design, not a time pass class for RCC. Learning means correct learning. 2.785 meter. Okay. 2.785 meter. Okay, now 1 minute. In the question given, this length is restricted to 1.05 meter. That's all. In the question given, see, due to some problem, maybe some restriction is there from center of column, the projection, the footing should not extend this side by more than 1.05, or make a note, instead of telling 1.05 from center of column, it is possible that they can tell this distance. What is the answer? Those who refer from center of column, if they tell restriction comes at 1.05, tell me what is the restriction from outer face of the column? Answer. If instead of telling 1.05, tell the restriction from outer face of the column. Outer face of the column. How much? They can refer 0.95 meter. So both are same meaning. 0.95 meter. See, now in the question you can write widthwise from the face of the column, one side, say that side, back side, you cannot extend the footing or provide footing by more than either 1.05 from center of column or 0.95 from face of column. Okay, now I told you, first you do not see that one. First you try our usual procedure of equate projection. Who knows? When they told 1.05, it may be possible. I told this earlier. Anyway, first you solve systematically. Now, tell the answer here. L2, 2.785. Tell me, what is the maximum L2 possible? What is the maximum L2 possible? See, how much you go this side, same amount you should go this side. Otherwise, column will become eccentric. You should avoid eccentric. See, column eccentric is worst case than bad footing. If one length is more, other length is lesser. If it is concentric, it is better. Placing eccentric column is to be avoided as much as possible. To be avoided. That is the last resort. Answer, tell me. Those who refer 1.05, see, it is from center of the column here, this distance. So, what is the maximum L2 possible? No, if you refer this 1.05, how much? Answer. If you from center of column here, restriction is 1.05. So, what is the maximum L2 possible? This much time, 2.1 meter. Why? It it is 1.05 into 2 is 2.05. Or those who refer this distance, what they will tell? It is 0.95 plus 0.2 plus once again what offset there? Same offset here. Once again plus 0.95. Oh, same answer. Yes or no? Irrespective of referring from clear projection or center projection from center, L2 restriction is how much? 2.05 meter. This clear or not? Clear or not? 2.1 now. Then who told 2.1 meter? Then who told 2.05 first? Someone told that 2.05. Otherwise I won't write. I agree. 2.1. This is also 2.1. Therefore, see, if you see, now write a story. If you want, see, now make a note here. See, problem. If you want lengthwise projection equal to widthwise projection, then tell me what is the L2 required? Tell the answer. And what is the L1 required? L2 required is 2.785 meter. L1 required is how much? 3.385 meter. Now, is this 2.785 possible or not possible? Tell the answer. Is that 2.785 possible or not possible? The 2.785, is it possible or not possible? We do not want eccentric column. Not possible. Suppose possible, then this condition has no value. Clear? Suppose the question given, this restriction is say 1.5 meter. Then 1.5 plus 1.5 up to 3 you can go. Up to 3 you can go. You don't require 3. Then you provide 2.785 only. Just because 3 is available, don't provide 3. How much you require? 2.785 you require. But now, right here, L2 of 2.785 meter is not possible. Not possible. Therefore, but how much possible? But what is possible? What is possible L2? Tell the answer. 2.785 is not possible. What is possible L2? Possible L2. 2.785. If it is possible, this question I would not have solved. It is same as last time question then. Possible is 2.1 meter. Therefore, you make a note now. Your equal projection case will exist here or will not exist here. Equal projection lengthwise widthwise will exist here or will not exist here. Equal projection lengthwise widthwise will exist here, will not exist here. Will not exist here. Leave it. So, column is still concentric only. These people usually call this as what? Tell me. If projections are equal, see last time example, if you remember, lengthwise bending moment, widthwise bending moment, we almost got equal. Remember or not? Last time, lengthwise bending moment, widthwise bending moment, we almost got equal. Tell yes or no? Last time, almost equal. So I don't remember the value. Last time, we got lengthwise BM and widthwise BM almost equal. Yes, that is because it is the most economical design. But now, due to problem, lengthwise, widthwise projection problem is there. Therefore, you take L2 equal to 2.1 meter. Tell me. Then, what is L1 required? You see, you require L2 of 2.785. You cannot give 2.785. You can give only 2.1. So, L1 you have to increase. Tell the answer. Then L1 equal to, what is the area required? Area 9.428 divided by 2.1. Answer. 9.428 divided by 2.1. Answer. 9.428 divided by 2.1. 4.49 meter. 4.49 meter you require. So round up to 4.5 meter. Nothing can be done. I told you long back in Bangalore at a particular place I have seen a column putting of width equal to 2.5 meter, length equal to 6 meter. Now right here, therefore you provide what? L1 equal to 4.5 meter. Therefore, remember, make a note. Now, what is the problem? Now the problem is that what? This footing projections are not equal, therefore it is not economical but helpless. We do not want eccentric column. So people, practical field, call this as what footing? No doubt concentric only. They use a word for this one. When one side is too long, other is short, later one side heavy bending will come, other side less bending will come. So last time balanced bending. Once heavy bending means depth required is more, shear is more critical, helpless. We can give more depth and more steel. There's a technical term used practically. What they call this? Tell me. Not eccentric. It is not eccentric. I told not eccentric. Concentric only. There's a name. If you can make the projections equal, people call it good footing. I told earlier. If you cannot maintain equal projection, people call it what footing? Not good footing. One word they are using. Practically one word they are using. It is not, how it is eccentric? How it is not eccentric? How eccentric it is? It is called bad footing. But remember, bad footing is better than what? Tell me. Good footing is always good. Bad footing means okay, bad. But it is better than what? Bad footing is better than. Bad footing is better than. Tell me, bad footing is better than. Bad footing means because one side heavy bending, one side lesser bending, therefore steel and depth will come, RC depth of footing and steel will come more. People not bothered. Eccentric. Now do one thing, make a note. Suppose you go for same thing, see, 1 minute. Suppose your L1 required is, how much answer earlier came? 3.385. L2 2.785. See, suppose the column is here. This is restricted to 1.05 meter. Now, you want L2 2.785. Suppose you provide, see, 2.785 here. Then you can give length of how much? 4. Where is the answer? 3.385, say 3.4 meter. Then your footing will become, see, your footing will become 1 minute. No, not that way. Your footing will become, central line is here. It will become this way, correct? It will become this way. This is 1.05 meter. This will become from 2, suppose you give 2.8 meter. Why? 2.785, 2.8. This will become 1.75 meter. Clear? This will be what footing? Tell me. This is called what footing? If you don't maintain, if you don't give equal, either side same, this is called what footing? This is called eccentric footing. Ayyo, this is worst case. Nobody will tell, no, this side do not want. See, they will tell this side do not want. Instead, you tell, then you have to go for something like this. They will tell, okay, this is unwanted. Go for this one. But heavy bending will come. So what? More steel and more concrete. Okay. Stability. See, stability. Therefore, this is ruled out. If such a situation comes, then your eccentric load becomes what? It will produce again one moment this way and one moment this way. So then what will happen? Then column will be critical then. Stability problem will come. Therefore, that is to be avoided. But if it comes, you do in the SAFE and ETAB, you make the model, it will tell you safe or not. But therefore, they will tell, this is C. People will tell this way. This is good. When these two are equal, good. This is little bad. They will tell, this is worst case. Hey, no, don't go. It is better to go for bad than worst case. Clear now? Good is good. Bad is okay, bad. But it is not worst case. This is worst case. Full clear? So go for bad footing. Clear or not? Go for bad footing. Okay, now start. Let time required now. Therefore, we decided finally that our footing dimension is what? At present, trial. Your L2 equal to 2.1 meter and the ಎಂಥದ್ದು ಇಲ್ಲಿಗೆ ಈಗ ಸ್ವಲ್ಪ ಮತ್ತೆ ನಾನು ಹೇಳ್ತೇನೆ ಮತ್ತೆ and L1 required, L1 you are providing is how much I forgot now, 4.5 meter. This is the column. Okay, now axial load P, one moment this way, one moment this way. This is, see, this is the axis 1 told 1000 times. This is the axis 2 told 2000 times. This moment is called M1. This moment is called M2. This moment is called M1. This M1 is, how much I told you? 140 kilonewton meter. This M2 is, I told, 200 kilonewton meter. And axial load P is 1250 kilonewton. Now, calculate what is the maximum, what is the PG maximum and what is the PG minimum. Fast, I want answer. Tell the answer. PG maximum, fast. PG maximum, bega, fast time. PG maximum. Answer. Load is, there is axial load, 1250. One term is 145.503 M1 by Z, M2 by M1 by Z1. First answer. I got PG maximum, I don't know. .05 kilonewton per meter square, and PG minimum comes 74 positive, 74.955. Tell me, correct or wrong? You can use Excel also. Is it correct? Tell the answer. PG maximum, PG minimum. Correct answer? I don't know. Check it. Fast. Check fast. I will tell you this question. Practically it happens sometimes. So later in ETAB and SAFE class, I won't waste time on these things. Got the same value. Now, this is more than SBC of soil of only 175. Therefore, not safe. Positive, okay. Now, tell me, revision required. When revision required, see, I'll remove this one now. I may ask you questions about the values. When revision required, somebody who comes first time today's class, he will start wondering what is happening. Let him wonder. Class I am conducting for those who are regularly coming. Okay. Now, tell me, earlier what we did, we increased both L2 and L1. Tell me yes or no. Earlier we increased both L2 and L1. Tell yes or no. First. Earlier we increased both L2 and L1. Yes. But today we cannot increase L2. We can increase only what? We can increase only what? Today we can increase only. This is going to be a worst case of footing. I have set the question so that one side heavy bending will come. L1. So I will now try L3. Remember, make a note. L2 equal to 2.1 meter is fixed. It is fixed. No change. So try L1 equal to, I will take a ratio here, 216 by 175. Too much more required into 4.5. It comes to 5.55. I will try 5.5 meter. Okay, try. Then, no, it happened. I have seen such footings where widthwise only around 2 meter, lengthwise around 5 meter, unavoidable case. But if widthwise around 2.8 meter, 2.5 meter is there, this can, around 4 point something is sufficient. Let us consider a worst case. Then your PG max will be PG max and PG min. I tell you PG max to P. One 189.59. This is positive. Therefore, still more than 175. Okay. Go for one thing. Or one more resort. Try L1 equal to 6 meter. Early, midway, no problem. Somebody may tell 6 meter. Yes, 6 meter. Someone will tell better go to combined footing. Yes, that option is there. If such a abnormal size comes, you can go for combined footing. But let us continue this problem so that you learn it. Somebody may tell 6 meter. Yes, I think better club with another column and a combined. Yes, that you can do. But here you are learning. When you learn this one. Practically change it. Go to combined footing. Okay. Now your PG max equal to L1 is 6 meter now. Where is it? 1250 into 1.1 divided by 6 divided by 2.1. Answer you got plus 6 into moment is 140 divided by 6 divided by 2.1 square, then plus 6 into 200 divided by 2.1 divided by 6 square. 156.746. I think this is wrong, I think. Check the answer. I think this is wrong. Tell me, when L1 is 5.5, what is PG? When L1 is 5.5, I think this is wrong. I'll check once again now. How much it is? 5.5. 2.1 square. Oh, that is wrong. It is 172.57 kN per meter square. Okay, sorry. Therefore, tell me, more than SBC or less than SBC? Fast. When I tried 5.5, it became 172.57. So, more than SBC or less than SBC? 172. 156 ಅಲ್ಲ, ಕರೆಕ್ಟ್ ಆಗಿದೆ. See, when it is ಕರೆಕ್ಟ್ ಆಗಿದೆಯಲ್ಲ, when it is 5.5, 172 ಅಲ್ಲ, it is getting 172. I think you are not done 1.1, I think. See, I think you are not done 1.1. Yes or no? One who gave the answer 156.75, most probably you are not taken 1.1. Most probably. I'll check it. This point. What is your answer? 0.75. No, I don't know. I want to know. Now correct answer. Oh. Is this answer correct or wrong? First tell me. Is this answer correct or wrong? If correct, I will proceed further. Is that 172.57 is correct or wrong? Okay, correct. Thank you. Leave it now. Other is positive. Over. Therefore, I will come to conclusion now. So this is a bad footing, helpless. Say therefore, this footing at present the finalized value is what? See, our finalized value, this is the footing. See here, little problem. By looking only you can make out one side is too small, other side is bigger, and see, it is like this. Okay, no problem. Salpa, Inisha, I'll do one thing now. I'll show it the actual shape. It is like this. Helpless. How much here? Same here. Okay. This is the footing. Some will tell, see, this dimension is 5.5 meter. 5.5 meter. This dimension is 2.1 meter. And this column side is 0.8 meter. This column is 0.2 meter. Anyway, now A, B, C and D this way. Now I want net pressure calculation. Net pressure calculation. Remember, net pressure is what? Plus P by A plus M1 by Z1 plus or minus M1 by Z1 plus or minus M2 by Z2. A equal to L1 into L2 equal to 5.5 into 2.1 and Z1 M1 equal to how much? M1 is this one 140. Z1 equal to Z1. This is the axis. Which one? This is 1 axis. Z1 is 5.5 into 2.1 square by 6. Z2 is 2.1 into 5.5 square divided by 6. Therefore, tell me net pressure at A, net pressure at B, net pressure at C, net pressure at D. Tell the 4 net pressure fast. Tell me the 4 net pressure. Okay. I'll take a small break now. Not break actually. Take rest. After today morning I went somewhere, some outside relative's place. Came just now. So not tired. But so in between, some 5 minutes useful for me. You calculate the 4 net pressure. Okay. Wait. This question will continue maximum. I will not solve like last time. I will leave the question when it reaches a stage, or I will do fast solution. We are starting combined footing today. And in the beginning, pressure calculation, I will do combined footing and draft. It is common. I will fully make it clear today. Don't worry. Okay, start. Go for the 4 pressure calculation. Don't waste time. If you finish, take 2-3 minutes rest there. No problem. Take little 2-3 minutes rest. Tell the answer. Net pressure. 1 minute. Net pressure at A, how much? Okay, I will enter the value here. I will tell net, black color will write. So that later I can convert it. 1 minute. I will write here, net pressure at A equal to, how much you told? 54.7. Are you sure? 54.7 kilonewton per meter square. Net pressure at B 92.46 kilonewton per meter square. Net pressure at C 151.76. Net pressure at D 124 kilonewton per meter square. Now one thing, just for checking purpose, you add the 4 values, tell me, just for checking purpose, you add the 4 values first. Suppose by chance wrong will continue. Why? See, if I look, I can make out, it is reasonably correct. I got a feeling. So, don't bother, our purpose is learning. I do not want to waste time again by calculating. Okay. Add the 4 values. Just add the 4 values. I will apply a common check so that I can make out if any major mistake is there. Add the 4 values. How much you got? 432. Multiply with 5.5. Multiply with 2.1. Answer. Add the 4 values. Then multiply with 5.5 and multiply with 2.1. Answer. Multiply with 5.5 and multiply with 2.1. Answer. Divide by 4. Divide by 4. You should get back the column load. Divide by 4. You should get back the column load. Y means you don't bother. Coming? Okay. Therefore, no problem. So, if any still, remember, sometimes if you make a mistake in M1 by Z1, format is correct. That error you can't see here. But I can make out by looking that this is reasonably okay. Leave it. Suppose someone will calculate and get different answer and put a comment, I will tell, I told in the class, this is for learning purpose. Why should you bother? You continue with this value because time, or I will tell him, in that case you should have come live and told. Nobody who comes live has any right to comment on numericals. If technical mistake is there, you comment. I agree. Okay. Now, tell the answer. What is pressure? Average pressure here. What is average pressure here? This will give you average pressure. See now, what I told is, see fast. Because I want to continue and bring to a state this question. Because this is important question. See, now, if I go for design purpose, lengthwise cut. See, lengthwise cut. You can see like this. I won't waste time now. Briefly I will tell this way. Is the lengthwise cut. Widthwise cut, you can see like this. Refer the previous question, study thoroughly. Over. Start. Lengthwise cut, pressure variation. Tell the answer here. Average of these two pressure, 54.7 plus 124 divided by 2 is the pressure here. How much? 54.7 plus 124 divided by 2. See, you will take one strip here for lengthwise bending, one strip here for widthwise bending. That all told hundreds of times earlier. So I am doing only important part. Those who are serious, make a full fair copy referring to previous question. Answer. 89.35 here. 89.35 kilonewton per meter square here. And here pressure. How much? Here pressure. 161.76 plus 92.46 divided by 2. This pressure. This is the pressure variation for lengthwise bending. This pressure. How much? 127.11. Those who are thoroughly studying understand. People who come suddenly and want to understand this, it is their problem. This is the pressure diagram. Okay. Now, widthwise bending. See, this way. Tell the pressure here. Here pressure. 124 plus 161.76 divided by 2 is the pressure here. For widthwise bending. I am not writing sketches like last time. Like show a cantilever, show bending, all. That all you do yourself only. First of all, I should stop the question here. But there is a reason for continuation. Here, answer. 142.88. 88. Here, pressure. That is center here, pressure. 54.7 plus 92.46 divided by 2 is the pressure here. This pressure. Now see, one cantilever here, one cantilever here. That all you know it. 73.58. Okay. 73.58 here. And now, see, further sketches refer last time. For lengthwise bending, we will take a cantilever here. This cantilever. So, I need this pressure by interpolation. For widthwise bending, we will take a cantilever here. Other cantilever is not required. I told you earlier. Other cantilever is not required because lesser pressure. Tell me this pressure. By interpolation, tell me this pressure. By interpolation, tell this pressure. How much? This is 89.35. This is 122.1. That is for length of 5.5 meter. So, you 1 minute. Before that one, I want these two projections. Tell the answer. Projections. 5.5 minus 0.8 divided by 2. Lengthwise projection. And also, I want widthwise projection. They are not equal today. Too much difference is there. It is a bad footing. Lengthwise projection. How much? Lengthwise projection. How much is the lengthwise projection? 5.5 minus 0.8 divided by 2. Lengthwise projection. Why? 2.35 meter. Heavy projection. 2.35 meter here. Here also 2.35 meter. Widthwise projection. 2.1 minus 0.2 divided by 2. 2.1 minus 0.2 divided by, why calculate? It is 0.95 meter and 0.95 meter, correct? 0.95 correct? Widthwise projection is 0.95. Okay, now start. Tell me, what is the pressure here by interpolation? What is the pressure here by interpolation? This pressure by interpolation. This side is not required, unwanted. Here, this side is unwanted. This pressure here, tell first. This is 89.35. This is 122.11. Interpolate and tell this value. Agalwa, that much difficulty? Is it 108.11? Is this answer 108.11 correct? Tell me. Is 108.11 correct? 110 now. How? 122.11 minus 89.35 divided by 5.5 into 2.35. That one you subtract from 122.11. My answer is correct. 110 now. How? How? Oh, is it 127.11? Oh, print mistake. Okay. Then 127.11 minus 89.35 divided by 5.5 into 2.35, subtract from 127.11. Okay. 110.98. Correct? 110.98. Because wrong writing. 110.98 is the pressure here. And this pressure is $111.53. This pressure is 111.53 by interpolation. This is by interpolation. Correct? 105. 142.88. I got 111.53. What is happening today? 110.976. Adayitu. Idu 111.53. Is the pressure correct? I have written correctly. 142.88, 73.58. Correct answer. 142.88 minus 73.58 divided by 2.1 multiplied by 0.95. That much you subtract from 142.88. Correct, I think. 111.53 is correct. Left side projection. What is this left side projection? What is left side projection you are telling? This way if you tell what I don't make out what you are telling. 2.35, correct. 2.1 minus 0.2 divided by 2 is 0.95. What is wrong? 0.95. So what? I think this is correct. 111.53 is correct. Just check it. If I write a if it is 0.95, this number is correct. So because of some writing problem, it may take place. I entered correctly there. 142.88. What you told, I entered. Other one is 73.58 you told here. Then 111.53 is correct. Then why? Okay, now do one thing. Calculate. Now you do it. Calculate. See, I will not waste time now. Now you calculate this bending moment and calculate this bending moment. Okay, you calculate. Okay, I will give direct answer. No time to explain. 110.98 plus twice of 127.11 divided by 110.98 plus 127.11 into 2.35 divided by 3 is the distance 1.2, correct, multiplied by 110.98 plus 127.11 close divided by 2 into 2.35. This bending moment is 336.14, and this bending moment this is the maximum BM for lengthwise bending. Sorry, I told so clearly earlier, resultant load into distance, how much I explained earlier, and there 111.53 plus twice of 142.88 divided by 111.53 plus 142.88 into 0.95 by 3 is the distance multiplied by 111.53 plus 142.88 divided by 2 into 0.95. That bending moment is only 59.76. See there, lengthwise bending is so heavy, 336.14. Widthwise bending is only 59.76. And here. Okay, wrong means no problem. Clear now? Okay, lengthwise bending 335 point. I got 335. Okay, I will stick to my answer. A second time I can't check now. I got lengthwise bending BM 335. Adengagate 110.98 plus 127.11 divided by 2 into 2.35 is the total load into bracket 110.98 plus twice of 127.11 divided by 110.98 plus 127.11 close the bracket into 2.35 divided by 3. I got 336. My answer is correct. Okay, correct. Okay, now these are the actual BM. Therefore, see shortcut. What is the factored BM for lengthwise bending? And tell me what is the factored BM for widthwise bending? Shortcut answer. What is the factored BM? Lengthwise bending factored BM. This is working load BM. Tell the answer first. I don't want to calculate. Factored BM for lengthwise bending. Is it 504.21? This is 504.21 kilonewton meter. That factored BM is 59.76 into 1.5 is 89.64. Tell me, I am telling you why I am in city's question. Okay, these are the value. Now, to fix the depth, D, equate mu to mu limit. That is based on bending. Based on bending you fix. Based on bending. Okay. Mu means which one? Higher mu. Higher mu you decide. Or higher mu is how much? 504.21 10 to the power 6 equal to 0.36 into xu max by d into 1 minus 0.42 into xu max by d into b is 1000 into d square into fck is 25. Tell the answer. What is the effective depth d required for lengthwise bending? Millimeter. Answer. Other check is not required. Lesser, higher BM. Tell me, what is the effective depth d required for lengthwise bending? What is the effective depth d required for lengthwise bending? Because some important concepts are there. That's why I am telling it. Otherwise I will not tell. When you go to Excel or ETABS, I will tell this once again. Long back solved, remember. What is the d required for lengthwise bending? 504.21. You are not giving any answer. Divided by 0.36 divided by xu max by d divided by bracket 1 minus 0.42 into xu max by d equal to divided by 25 divided by 1000 equal to root answer. 388.53 I got. 388.53. 388.53. Therefore, now do one thing. This question you should be careful. See, tell me, widthwise bending is so small, lengthwise bending is very huge. Therefore, this time what you do is you insist that what? Insist in the drawing. In the drawing, send to site that steel for which one? Tell me. Lengthwise bending to be placed first or widthwise bending to be placed first. You have to give a section then. Because this time it counts. Why? One of them is huge bending, other is less bending. So you write a note here. For lengthwise bending, you want to get higher D or lesser D. You place the steel in such a way that effective depth available is more for which bending? Tell me. Effective depth available is more for which bending? Tell me. You should provide the steel in such a way that effective depth D available is more for lengthwise bending. So for steel for lengthwise bending, that is, you insist there. See, this is your lengthwise bending, heavy projection. You tell them, see, in the drawing you tell, no, see, you place this bar here. This is AST for lengthwise bending. And see, that is this AST. And this is AST for widthwise bending. Jujube. AST for widthwise bending. You tell them, place it above that one. Okay. Now tell me. Therefore, you insist this one. And tell me, take what diameter? Do not take 12 torol. Heavy bending is there. This time be careful. You require high steel. So safer side, assume high diameter. Later, if you reduce the diameter, well and good. Tell how much? Not 12 tor, not even 16 tor. For lengthwise bending, better take higher diameter. How much? Lengthwise bending, very heavy bending is there. See, 2.35 meter cantilever. Widthwise is 0.95 meter. This bending moment is how much? 500. That is 59. 20. You better take 25 tor for lengthwise bending, safer side. Therefore, capital D required equal to what? 388.53 plus 50 clear cover plus 25 by 2. Don't take like last time. You insist. Now in the site, they will provide lengthwise bar first, then widthwise bar. If they place other way, you need not permit for concreting. You tell no, remove it, put once again. You tell them, sir, no problem, I am telling you, remove the steel. I will tell that way. In the drawing I have written, place lengthwise steel first, then widthwise steel. Or I will give a section for them. This section is given for them. Can't you see this one? Sir, usually you provide randomly. Then you go randomly somewhere and put your bar bending. Don't come to my site. Get out. I will tell, get out from here. 451 point something. Okay. Now, 451. Remember, this is based on bending. Based on bending. Now, shear is very critical. Increase by how much percent? Better. I told at least 75% or double. Tell the answer. What you take? Better take double. Double. Why? Therefore, try capital D equal to, how much? Tell me. Try capital D equal to. Try capital D around. Capital D fast. 900 millimeter. 900 millimeter. Okay. Now, if you take capital D 900, then what is the D for lengthwise bending? Actual D. Actual D is 900 minus 50 minus 25 by 2. Tell the answer. Actual D available. See, these all we did not get in the last time question. That's why even though I announced combined putting, I decided better complete everything. No point in giving half knowledge and then just to complete the course. I can't do that way. My conscience won't permit. Answer D provided. We will go to combined putting today. It is 837.5 millimeter. And for widthwise bending, tell what diameter you will take. First of all, for widthwise bending, steel will come very, very small. Most probably you have to give minimum steel. So tell me, widthwise bending, don't waste steel. Take what diameter? Widthwise steel, take what diameter? You don't require high diameter. Lengthwise bending very predominant, widthwise steel. See, we have taken 25 torr. Later if you make 20 torr, well and good. With 12 torr, usually for footing, people do not want less than 12. Therefore, what is the D actual for widthwise bending? What you do? From 837.5, subtract half of that diameter, subtract half of this diameter. This is told very clearly in RCC 2A slab. Tell yes or no. First, tell yes or no. From that D, subtract half of that diameter, subtract half of this diameter. This is told so many times in the slab chapter. 819 millimeter over. Now, I will make a small note now. Lengthwise bending, 25 torr taken, D equal to 837.5. Widthwise bending, 12 torr taken, D equal to 819 millimeter. I will tell you why. Otherwise, I have to keep on asking. Okay, now, depth is fixed. Okay, now, 1 minute now. Later, when I check for shear, remember, if at all I check for shear, okay, I want to remember that value. If I ask you, you will take a lot of time to tell it. I will make a note. 110.98. If I ask you, you tell me, you already noted it down. If I ask you later, tell me the pressures here and here, you tell me comment box, you already noted it down. Okay, I already noted down here. Why? If you will forget later. Okay, now, most important part, depth is fixed. And bending moment I forgot now. Anybody can tell me lengthwise what is mu? I rubbed just now. What I see here only? 504.21. You don't require it. Widthwise mu is 89.64. Okay, leave it. Because I don't have to ask you once again now. I don't have. Okay, now question is almost getting closed. Start. Remember, depth of the footing slab is fixed. Now, first step is check for punching shear. Punching shear. See, sorry. David took Shamisi. I have got better work to do. Therefore, I will just give random values and then I will go to AST calculation. Reason I will tell you later. But one point is there. See, earlier question, you make a note. Earlier question, you don't bother about which steel first. We took D same for both. Yes or no? Earlier question, we took D same for both bending. Tell me yes or no first. Earlier bending, we took D same for both. Tell me yes or no. We took D for separate. We took D same for both. But this time, D's are different. So, later, when you check for other shear, lengthwise bending, you take D 837.5. Widthwise, you take 819. Why? Independent. But punching shear comes all round. All round. See, critical section for punching shear will come like this. Therefore, when you check for punching shear, this distance is at D by 2. This also at D by 2. Tell me the punching shear. Critical section is taken or considered is at D by 2 from face of column. Okay. Now there is a problem. Punching shear comes all round. A part of it, see, lengthwise also comes, widthwise also comes. Two different D values are there. Tell what to do. Tell me. Tell what to do. Tell what to do. Along one periphery, D is more. Other periphery, D is lesser. Not too much variation, slight variation. So what people take is D, right? Since D's are different, consider average D. See, even your ETAB and SAFE also will consider average D. You see, right click on ETAB, it will tell you D for this one, so and so, D for this one, so and so, so average D is something. Tell me average D equal to answer. I should not explain how to find average D for these two. One of them is 837.5 plus other is 819 by 2. Tell the average D first. Average D. 837.5 plus 819 by 2 is the average D. 828.25. 828.25 is average D. Remember. So for punching shear, you take D equal to average value of 828.25 millimeter. Okay, leave it. Now tell me what is D by 2 equal to? D by 2 equal to. Okay, D by 2 you write yourself only. You write D by 2. Therefore, tell what is this dimension, both I want in meter. Okay, now it is your problem. Okay, start. I'll start the calculation now. This is 800, that is 0.8 plus 0.82825. Correct average D. This dimension is 1.62825. 1 paisa, 2 paisa, no problem. This dimension is 0.2 plus 0.82825. 1.02825 is this dimension. That's all. Now you start. I will give you number and I will continue after a little time. Okay, start. First, punching shear force. Punching shear force VP equal to, for that one, remember, I will not tell too much now, sorry. There is a limit for explaining. 1250 divided by, what is the area? 5.5 divided by 2.1. Remember, that information for you. Net pressure at the center of column, you know how to find. I thoroughly explained last time, is 108.225 kilonewton per meter square. Anybody, if it is not clear, go back to previous class, go back to class number 1 and come back. Punching shear force is (1068.8 kilonewton) and factored punching shear force is, sorry, I should not explain, 1603.2 kilonewton, and average punching shear stress tau EP is something wrong. I am having a feeling something is wrong. 1 minute, I'll calculate. The perimeter into 0.25 is the area. No, it's correct. It is 0.3643 Newton per mm square. And we want tau Cp. This is the actual stress. This is the allowed stress. Allowed stress you calculate. It will come 1.25. It is 1.25 into 0.75. I am not explaining what is 0.75. Is 0.9375 is the allowed stress. Therefore, tell me, safe or unsafe? See, this time, because of the high D, critical section is going much away. Because critical section is going much away, what happened? That advantage is that punching effect got reduced. Okay. Point. And one more thing, because of this eccentricity, huge area is there, depth is more, so punching became safe. Therefore, safe or unsafe? First, punching shear stress is 0.3643. Punching allowed stress is 0.9375. Tell me, safe or not safe? Safe or not safe? 414.125 ಏನದು? ಅದು ಬೇಡ ಬಿಡಿ, ಆಗೋಯ್ತು, ಎಲ್ಲ ಮುಗಿಸ್ಬಿಟ್ಟೆ ನಾನು. I finished everything. Therefore, tell me, safe or not safe? Safe. Okay. Therefore, safe. Okay. Once it is safe, I will give it more work for you. Do one thing. Start. Calculation of reinforcement. AST. First, lengthwise bending. I will give it work for you. Lengthwise bending. MU equal to, I wrote somewhere, where I wrote MU? MU is there. 504.21 kilonewton meter. And capital D equal to 900 millimeter. And with the 25 torque for lengthwise bending, effective depth provided is 837.5 millimeter. So, substitute in the MU equation. MU equal to 504.21 10 to the power 6 equal to 0.87. Fy is 500 into AST into D is 837.5 into 1 minus AST into Fy divided by 1000 divided by 837.5 divided by FCK. Tell what is the AST required for lengthwise bending. You finish this much, we can almost close the question in another half an hour and then start combined footing. Start. Now, don't waste time now. This you check first. You check this one first. Or you can depend on me. Suppose wrong means okay. Important, but you can check, it is not a big issue. It is not a big issue. Shear, this is correct, I am sure. You can, not a big issue. You check that one and find what is the AST required for lengthwise bending. Okay, just some 5 minutes. Because they are calling from downstairs for evening coffee. I will have coffee and come. So, first you check for punching shear. You tell me AST required for lengthwise bending. Sufficient. That's all I am asking. Further I will not ask. Shear check I will fast give you and go to the next question. That is combined footing. We will start today. You will start. And punching check you do later. No problem. No point in wasting time. It is correct actually. I can make out. Now see, I will tell you why this question I have taken. So that later nobody can tell this is not covered, that is not covered. Tell the answer. 1433.1433. Is it correct? Tell first. 1433 is correct. 1433 is correct. Fast tell me. 1433, is it correct? I got doubt about that value. I got doubt about that value. See, 504.21, 10 to the power 6, alpha equal to 0.87 into 500 into alpha A into 837.5 into bracket 1 minus alpha A into 500 divided by 1000 divided by 837.5 divided by 25, close. Shift solve. Where at solve? How to solve now? Alpha equal to. No. Where is the mistake? I had to go for shift solve, I think. Shift solve equal to. No, error comes. I forgot the solution. Is 1433.046 is correct? Okay. Correct. Okay, down. Now one problem comes here. Tell what is the minimum steel. This is the main problem. Minimum steel is 0.12 by 100 of 1000 into 900. Answer. Minimum steel. 0.12 by 100 of 1000 into 900. Minimum steel. How much? There is a problem here now because you are helpless. Minimum steel, how much? 1080. Okay. 1080. Okay. Therefore, this I will remove. I will go further now. This I will remove. Therefore, for lengthwise bending, AST to be provided is how much? 1433 mm square. Okay. You took 25 torr. See what happens now. With the 25 torr, calculate spacing. Pi by 4 of 25 square divided by 1433 into 1000. What is the answer? 25 torr spacing. How much? 25 torr spacing. 1080. 25 torr spacing. Pi by, see the spacing now. If the spacing is very high, reduce the diameter. Reducing diameter is always safer side. I told thousands of times. 342.55. 342 point, how much it is? 0.55. Okay, one thing. 55. This is too high. Why? Such a foundation at nearly more than 12 inches, nobody will give the bar. They want compact arrangement. Therefore, better you try 20 torr. Okay. Remember, I told you repeatedly, reducing the diameter means your D becomes more safer side. If you go to 20 torr, what is the spacing? Tell the answer. Spacing. If you go 20 torr, spacing. Pi by 4 of 20 square divided by 342.55. Divided by 1443 into 1000. Answer. If you go 20 torr, spacing, it will become lesser now. Into 342, it will become closer. How much? 290. Okay, 290. No. Or, still better, go to 16 torr. If you go to 16 torr, what is spacing? Spacing. pi by power of 16 square divided by 1433 into 1000. If you got 16 torr, pi by power of 16 square divided by 1433 into 1000. It will come down. How much? 140.31. 140.31. Okay. Therefore, better give 16 torr at how much? Tell me. Little liberally provide. Huge footing. Heavy cantilever. Therefore, little liberally. Safer side. Tell the answer. 16 torr at. Not 140. To be safer side, little lesser spacing. Little closer. How much? 135 beta. Still liberal. Provide 125 millimeter center to center. Little liberal. During design, remember, such critical cases, see, this is a huge cantilever. So better, little closer. Okay, no problem. Instead of 135, little liberal, 125. Enjoy. Tell the footing, you enjoy. Okay, then, same way for, I'll do one thing now, widthwise bending. See, you don't waste time. Your MU equal to very small, how much? 89.64. And your D equal to, with 12 torr you have taken, your D equal to 819. So substitute here, at 89.64, where is the equation? If you substitute here, you get 89.64 10 to the power 6 equal to 0.87 into 500 into AST into 819 into 1 minus AST into 500 divided by 1000 divided by 819 divided by 25. Tell what is the AST required? Fast. Very small AST will come. That is the, notice, you actually get upset now. Very small steel required, but you have to give minimum. No other way. Tell the answer. Actually, steel will come very, very small, but helplessly, you have to give minimum. Like, you travel only for 100 meters in auto rickshaw. Still, you have to give 30 rupees. Why? Minimum 30 rupees. You cannot give 100 meter if you go, you have to pay only 1.5 or 1.5 rupees or 2 rupees. Why? Kilometer is 15 rupees. If you go to 100 meter and get out from the auto, he will not leave you. He will tell, give me 30 rupees. Answer. This is helplessly how to provide. How much? AST required. Now I will wind up this question. Why? Further you can do it. 253.18. See, 253.18. But minimum is 1080. Therefore, you have to provide 1080. So, tell me, what is the 12 torr spacing for 1080? Pi by power of 12 square divided by 1080 into 1000. Answer. Pi by power of 12 square divided by 1080 into 1000. Answer. Pi by power of 12 square. See. (104) it comes. 104.72. Therefore, provide 12 torr at 100 millimeter center to center. Remember. Therefore, see, now, I will do one thing now. Check for shear. You can do it now. I don't want to waste the time. Because why? This is an extra question I solved for all these problems. Check for shear. Can you do it? Critical section at D. Lengthwise bending you check. Widthwise bending check is not required. If lengthwise bending check passes, widthwise will be laughing it. It will have such a small shear force. Lengthwise bending safe means widthwise bending 100% safe. Okay. Check for shear, do it, sir. Therefore, this here, the lengthwise bending steel is how much? It is 16 torr at 125 center to center. Widthwise bending steel is only 12 torr at 100 center to center. Some will tell Sir, that is more spacing. No, this is 12 torr, this is 16 torr. Remember, this is 12 torr, this is 16 torr. This is very, actually, if you, some will tell, you are giving where bending is lesser, you are giving closer. No, it is 12 torr you are giving. This is 16 torr. Even now, lengthwise steel is, I will tell you, 16 square by 12 square is so much, 16 square by 12 square, then divide by 125 into 100. Lengthwise steel is around 50% more than widthwise steel. Okay. Depth is 900. Now, here you can complete and you can close the question. I won't waste time. I will start what is promised earlier in the class link, that is combined footing. Shall I start? First, I first thought I will just give brief introduction and stop. Then I decided, no, when you take something, tell correctly. If I had not told all these things, you would not have been knowing all these things. Okay, now we will tell goodbye to what? Isolated footing. Now, very, very important. See now, remember, combined footing, there is some restriction. I will tell you. When you go to combined, I will give first warning. When you go to combined footing, you require SFD and BMD. And remember, in the class, I will not explain SFD, BMD for you. Why? I will put the diagram here. See, I will put the diagram here. See this combined footing, a column load here, a moments are here, and pressure diagram is like this. I will tell this way. And then I will tell or I may draw BMD on tension side. How? This way. Then remember, that's all because, tell the reason. I told information for both RCC batch and ETAB batch that when we go to combined footing, to draw SFD BMD, you should attend the class in the course BSK class or SFD BMD course in the link I mentioned. So it is your responsibility of studying. Those who attended that class, okay. Others, what diagram I give, you should accept it. Remember, BSK class in YouTube, I have given, see, RCC batch and both ETAB batch, I have given information. See, I am starting in SFD BMD or BSK batch. Today I am starting SFD BMD for combined footing. Two cases are there. Once the column is nearby, once the column is far off. Therefore, later in combined footing, I will draw the diagram. But reinforcement I will tell you. Reinforcement part I will tell you. And this SFD BMD I will not tell. Or what I will do is, in the class, I will adjust so that end of the class, I give you loading diagram. Loading diagram. Maybe not today. Today I got pressure calculation. Next Saturday, I will correctly finish the loading diagram. Then I will tell, see, tomorrow class, we are going to close the combined footing. But before that, I want SFD BMD. Same day, you should draw SFD BMD and tell in the next class. Agreed? Remember that V dash X, M dash X all. Remember or not? So, same day you draw the diagram, next time you get ready. Okay, start. Now, do one thing. See, you make a note. In this course, I am continuing RCC design. At present for anybody. But this anybody class will stop little later and after another 1 or 2 classes. Add. Now, columns I did and footing, isolated footing already over. This is for general public. Anybody can see. Now further, I tell here now. Once you have to go for combined footing. Those who are in the RCC batch or ETAB batch, that is the main purpose. And further, RCC batch will stop there. But ETAB and SAFE batch, you also require building design, footing design like this. Tell what is this one, tell me. Random column placing. This footing also you have designed using software. What this is called? What this is called? What this is called? Combined footing, okay, not this way. Combined footing is like this, see. What this is called? Raft footing. So here raft footing, too much of manual calculation is not possible. Very lengthy. So raft footing for getting SF and actually no SFBM. For design we will go to software. But remember, even if you go to software, see, even if you go to software, tell me, L1 and L2 you have to fix. In practical design, software will not fix L1, L2. Therefore, L1, L2 you have to fix. Tell me, L1 and L2 you are fixing based on pressure calculation. So that PG maximum is not more than SBC and PG minimum is not negative. Remember or not? Maximum gross pressure should not exceed SBC. Minimum gross pressure should not be negative. Remember or not? First. Or forgotten now? Okay. Now, what to do for this one? I will tell you. Again, your earlier Excel is not valid. That is for isolated. A new Excel is there. You have to prepare it. But remember, you can prepare Excel for this one. If you prepare Excel for this one, it can be used for this also. Tell why? See, I will call column number 1, column number 2, column 3, column 4. You prepare Excel sheet for 4 columns. Then, if you want to use for combined putting of 2 columns, data for 4th column, data for 3rd column, everything, give how much? Load, moment, solve. For 3rd column and 4th column, you have everything data, you leave blindly. Give how much answer? Tell me. You can give for data for 3 and 4 columns. What answer? Tell me. 0. But some people, distance will come. Distance you can give anything. Distance you can give anything because if 0 is there, no count. Or those who got patience can do one thing. I will tell the Excel for this one. In the same way I will tell for this one. Briefly, 10 minutes. Prepare one separate Excel for combined footing with 2 columns and one separate Excel for 4 columns. But remember, very simple. But to prepare Excel sheet, there is a problem. See, isolated footing, what happens? Tell me. Directly see, isolated footing. I will put 3D sketch here. See, P, M1 and M2. Direct answer. Tell yes or no. P, M1, M2 direct data from the analysis. Tell yes or no. Isolated footing, column load, M1, M2 direct data from the analysis. Tell yes or no. Yes. But here, 1 P here, 1 P here, 1 M1, 1 M1 here, 1 more M1 here, 1 more M2 here, 1 more M2 here. Here, P1, P2, P3, P4 and 4 M1s and 4 M2s. So, you should know how to prepare Excel sheet. So, therefore, shall I tell the principle for 2 columns or 4 columns? Tell me. Shall I tell the principle for 2 columns or 4 columns? You think a little. If I tell principle for 2 columns, 4 column will be clear, or if I tell for 4 column, which will be easily clear. I should tell the principle for 2 or 4 columns. Think a little and tell me. To make clear, I should tell the principle for 2 column or 4 column. Just think a little and tell me. If you want correctly understand both, it is sufficient if I take the case of which one? 2 columns. No. 2 column means you will have problem. When it is 4 column, you will have difficulty. No. If you study for 4 column, then 2 column is easy because 2 are missing. So therefore, basic principle I will explain for 4 columns. See, 4 columns. And this Excel sheet, remember, actually one more thing I will tell you. Actually, Excel you require only to fix L1, L2. Remaining all software is doing. You don't have to do anything. I will tell in the ETABS&SAFE class. See, now, first write. Consider, 1 minute now. If 2 column, it is called combined footing. If 4 column, we call what? Tell me. If 2 column, it is called combined, usually called combined footing. If 4 column, it is called what? If 4 column, people call it raft. But actually remember, raft also is what? Tell me. Raft also is what? Someone will comment today. He told combined footing heading. He had taken raft. I will tell, hey, see there. Raft also is what? Raft also is what footing? Raft also is what footing? Raft also is what? It is a combined footing only. So therefore, consider footing for 4 columns. Remember now, very important. I will give data for you now. See, there is a footing. See, correctly question. Very important question. Correctly understand. See, there is a footing provided for 4 columns. Now, since I am telling principle, I will tell lengthwise footing dimension is 1 ನಿಮಿಷ. 6.5 meter, and widthwise footing dimension is 5.6 meter, randomly given. Okay, then there are 4 columns. How are the columns is shown in the sketch. 1 column this way, see. 1 more column randomly placed this way. See, I will make this is this way, I will place it other way. Deliberately, I will explain so that 1 column is placed what? Lengthwise more, otherwise see, turned, just to understand. Okay, now, these are the 4 columns. Now see, I will call this as any column. Okay, I will take one thing. I will take column number 1, column number 2, column number 3, column number 4. Okay, I will give dimension for each column. This column is 200 millimeter, all millimeter, by 600 millimeter. This column is 230 millimeter. Actually, column dimension is required now 230 millimeter by 500 millimeter. This column 250 millimeter by 575 millimeter. This column is 575. Children will come. To avoid children, I will take 550 millimeter. Okay. This column is 300 millimeter by 300 by 500. I can't give 450 millimeter. All writing visible for you? Tell me. All writing visible for you or not? All writing visible? First, I will thoroughly explain this raft footing pressure now. All written values visible for you? Because I wrote it smaller. Okay. Now, in the sketch told that, see, this offset and this offsets are given. Remember, offsets are given with respect to free edge of the column. Okay. Now, I will tell you this distance. 6.5, around 4 meter here. If it is around 4 meter here, 2.5, 1.1 meter. No, 1.2 meter. If that is 1.2 meter, This is 1.2 plus 0.2 is 1.3 ಆಯಿತು. 6 ಒಂದು 4 4 ಒಂದು 5 5.3. This is 1.1 meter out of scale. This distance is little more 1.15 meter. Little shifted. Suppose the 4 columns are correctly symmetrically placed, you are happy. And this distance is little lesser, just 1 meter. These are the 4 column lengthwise distances. Widthwise, this is 1.05 meter. Any 1.05 is there? No. This is point little more, 1.1 meter. That 1.1 is not this 1. It is not this 1.1. 1.1 meter. Then this distance is 1.25 meter. This is 1.18 meter. Okay. These are the dimensions. Now, this column load is, see, I will tell you load here only. This column load is 1200 kilonewton. This column load is 250 by 550, little lesser, 900 kilonewton. This column load is 1100 kilonewton. This column load is exactly 1000 kilonewton. These are the column loads. It is not only column load, also moments are there. Moments I will show separate sketch for you. In one more sketch I will write moments for you. This time I will randomly show moments here. See, this is for thorough understanding. Okay, now start. Here there is a moment like this of 60 kilonewton meter. Moment this way of 40 kilonewton meter. Here moment this way, reverse, see, this way of 80 kilonewton meter. Moment clockwise, anti-clockwise of 60 andre ಒಂದು 50 kilonewton meter. Here moment anti-clockwise, here full ulta I am taking 60 ಬೇಡ, ಇದೊಂದು 45 kilonewton meter. And here moment clockwise of ಜಾಸ್ತಿ ಇದೆ, ಇದು 60 80 90 kilonewton meter. And here clockwise this way of 45 75 kilonewton meter. Here anti-clockwise this way of lesser 55 kilonewton meter. Tell me, is this sketch also fully clear? Remember now, actually what happens is when you go to rough footing designed by software, you don't have to worry this much. Usually people take total load, fix the area, and they increase by some percentage, provide the area, then software will take care of pressure calculation. It will tell whether pressure exceeds SBC or not. So you don't have to try, but for knowledge purpose I am giving. Okay, now that's all. Question is, find only gross pressure. Net pressure we don't require. Why, tell me? Because we are not going to manual design of raft. Find gross pressure. Gross pressure at 4 corners. 4 corners, say A, B, C, D. At 4 corners, taking self weight of footing as 10% of column load. Therefore, in the formula for P by A, not P by A, tell what you have to take. When you take gross pressure, account 10% extra weight due to weight of footing. Tell me, what number you have to take for P? It is told 10% here. What number you have, how much P by A? 1.1 P by A over. You write note. See, I am rubbing everything now. We know that gross pressure at any corner. Remember, I am giving this example only for knowledge purpose. Remember, only for knowledge purpose. Tomorrow nobody should tell he has done in the software, it combined footing and raft footing, but he did not tell us anything about pressure calculation. Suppose I want to check the pressure. He told software will do it, but I thought in his class he will give structural knowledge. So only for knowledge. Remember, if you learn, you are not losing, you are gaining. Okay. Gross pressure at any corner equal to plus 1.1 P by A plus or minus M1 by Z1 plus or minus M2 by Z2, where you take the full combined footing. See, this is your L1. I am going to rub now. Remember now, I am rubbing everything. Later if somebody will ask, sir, what is L1? I will tell why you came to my class. Your L1 equal to 6.5 meter. Your L2 equal to 5.6. See, today's class, we are not bothered about SBC. Practically, this maximum gross pressure should not exceed SBC. That is there. Okay, now, and write one axis. Do not see any of the column. You tell all the four columns, get out, get out. Only footing, you come here, come. Only footing, column, you stand outside. Column, you tell you stand outside. This is 1, 1. Oh, sorry. This is your 2, 2. I told 1,000 times for you. This is your 1, 1. Why I am telling? Because I am first recollecting or writing again the basic, then I will not explain. Now, tell the answer. Area equal to, once for all, plan area, L1 by L2. You know L2, you know L1, substitute and tell me the area in meter square. Fast. Area in meter square, fast. Third decimal sufficient. Area in meter square, third decimal accuracy sufficient. Bega, area 36.4. Area is 36.4. In a corner I will write for my reference, area 36.4 sufficient. Then I want Z1. Z1 is about axis 1, 1. I told repeatedly it is L1 into L2 square by 6. Answer. L1 is 6.5, L2 is 5.6. 6.5 into 5.6 square by 6. Z1. Third decimal sufficient. Later I will just walk out and ask you, get the pressure. Z1. 33.973. 33.973 meter cube. Okay. For my reference, okay. Z2 equal to, see, Z about axis 2, 2 is L2 into L1 square by 6. Someone who came new, he will ask, why you took L1 square there? Why you took L2 square there? Why you took L1 square there? My answer, just like that, just like that. How just like that? Just like that. No, I don't understand. I will tell, I also don't know. That's all. Then he will realize, oh, maybe he will see the class link there. Footing class number, today 10, I don't, 10. Oh, he told class number 10. Maybe class number 1, 2, 3, 4, etc. He would have told that one. So let me once again go back and study. If he thinks that way, he is what? Study oriented. Or if he thinks, this person won't tell anything, randomly write something without explaining, I do not want such people to see my classes. 39.433. Sometimes you have to be harsh, that much meter cube. Alright, closed, chapter closed. Now remember now, correctly put here, what, tell me, see, don't see anything here. You make a note, for the complete footing, you get one single load, called what, tell me, single load called, don't see there, Tell the answer. Symbol, a single load called, name. True center of gravity of footing. Name. No, result, I don't want resultant. Symbol, I will tell you later. If you are applying this formula, load should be acting here. That is called symbol. I know resultant, that is later. Tell me symbol. I will explain one by one, don't worry. Those who are not, so many of you are not knowing this, I think. At least today you will learn it now. P. I will write P, dot. Tell why dot I am writing. Because if I go to three-dimensional view, P is like this. That is like this. I cannot show. I am showing P like this. Then, don't see there. Because of this complete combined action, there is one moment here, which is about axis 1, 1. Tell what this is called M1. Because of this complete system, you remove all the columns, one moment, I don't know. See, be careful. M1 can be like that, or M1 can, see, you write here. M1 can be like that, or your M1 can be like this. Clear or not? You make a note. We do not know whether M1 is this way or this way. We do not know. So write one, either it will be like this or it will be like this. Clear? Clear or not? We do not know direction. Yes. Same way, one moment like this will be there. That is about 2 axis. It can be M2, or who knows, M2 can be like this also. Now, if M1 is like this, then plus here, minus here. If M1 is like this, minus here, plus here. If M2 is like this, plus here, minus here. If M2 is like this, plus here, minus here. These all I explained. And later, finally, only one of this will come. Only one of this will come. That we will be knowing later. Clear now? That we will be knowing later. Right now you cannot tell how it comes. Full clear or not? Okay. Now start. I am completely removing this sketch now. See, later, once I fix M1 and once I fix M2, if finally I put M1 like this, you write plus, minus. If I write M1 like this, write plus, minus. And lastly, if I conclude and tell M2 is like this, plus, minus. Or if I tell M2 is like this, lastly, plus, minus. Using that you give pressure. Clear? Don't ask me. This plus or minus, where plus, where minus, everything told for you. Clear or not? I am rubbing the board now. You are not told clear. Okay, thank you. Now remember, we want to replace this complete system by a single force P through CG of the footing along with a single moment like this, lengthwise moment, this way or this way, and one moment like this. Correct. Okay, start. Hey, go. Now L1, L2 not required for me. None of them required. So I will remove everything now. Yeah, this is required. Now see, what you do is, see, you got the distances. See, one column load here, one column load here, one column load here, one column load here. You write one more sketch where you mark distance to center of the column. See, start. Hey, go there. 200 by 600. You write one more sketch where you mark distances from center of the column. Center of the column. This is 1000 kilonewton. Hey, go there. Okay. So I want, see, from center of the column. Okay. This way. I want everything from center. Tell the answer. 1.2 I gave clear. This column is 200. Tell fast. From here to center of the column. Distance fast. Fast answer. I want distance from center of the column. 1.3. Okay. This is 1.3 meter. Tell me here. From here I told this is 1.1. From center of the column, this distance. Fast. How much? See, I rubbed it down. I forgot immediately how much I told. How much I told? Abba. So fast forgotten. How much I told earlier? No. What value? No, this, not this one. This distance. How much I told? Clear distance. Within no time I forgot it now. Next time I won't rub it. No. What is the clear distance given here? You can go slightly backwards in YouTube and check. 1.1. So 1.1 plus half of 500. Answer. 1.1 plus half of 500. Why? Longer side. Answer. 1.35. Thank you. This is 1.35 meter. Okay. Here 1.15 plus half of 0.25. 1.15 plus half of 0.25. Answer. 1.15 plus half of 0.25. 1.275. Thank you. See, remember now, what I am writing now is from center of the column. All distance I am writing is from center of the column. Okay. It had new, it had the Bartoitu. 1.275. All from center. Red color is from center. And here, 1 meter plus half of 0.45. Answer. 1 meter plus half of 0.45. How much? 1 meter plus half of 0.45. 1.225 meter. I'll rub it now. One more sketch you are right. 225. Okay, start. Width wise. I told, this already I told, correct? This 1.18. I already told earlier, yes or no? Is it already? Is it 1.18 already calculated or not? I forgot now. This 1.18, was it already calculated or confirmed? First. Otherwise, fast. Is this 1.18 confirmed answer? Is it confirmed answer? Is it clear? Oh, clear. Then answer. 1.18 plus half of 0.6. 1.18 plus half of 0.6. Answer. That was clear distance. 1.18, 1.48 meter. Thank you. 1.48 meter. Red color. Tell me here. 1.25 plus half of 0.23. 1.25 plus half of 0.23. 1.365. Okay. I write red color. 1.365 meter. Here 1.1 plus half of 0.55. Why longer side? 1.1 plus half of 0.55. I will tell you 99% people will not be knowing this one. At least learn. 1.375. Okay, thank you. All red colors are from center. 1.375. Last one. 1.05 plus half of 0.3. 1.05 plus half of 0.3. 1.2 meter. Okay, start. This is 1.2 meter. Red color. All from center. 1.2 meter. Okay. Now, see. Now write a note. See. Note. All this system we want to replace by, see, this complete system we want to replace by See correctly what you have tried. Or I will put 3D sketch. See, I will put 3D sketch now to make clear. This complete system I want replaced by a single axial load here. P, one moment like this. Arrow mark can be either this way or this way. We don't know. One more moment like this. Either this way or this way. This will be called M1. This will be called M2. Clear or not? First. Clear or not? First. Okay. Now, remember, there are two approaches. There are two approaches. One of them is called systematic approach. Other is called easy approach. Do you want only easy approach or first systematic approach, then easy approach? Tell first. Do you want only systematic approach, only easy approach, or first systematic approach and then easy approach? Your choice. If you think systematic, who wants? I want easy one. Tell me, no problem for me. It is your both. Means you want low. Therefore, write option 1. Option 1. Systematic. Means what you have to do is first front view. Front view. Write a line diagram. Write a line diagram. Tell the answer. The total length here. Front view means look from this side. Look from this side. Front view. Write a line diagram. That length first. That length first. I am going for first systematic approach. That length L1, you know it. I rubbed it. It is there still. 6.5 meter. Okay. Now, mark all the loads. You see from I will tell one thing now. This is the footing. Footing is, see, 1 minute. This is the footing. There are 4 columns there. See, 1 minute. I don't have 4 columns here. 1 minute here. Just a minute. If I remove the cap of the pen, within no time, pen will get dry. I will try to get something. 1 minute. I'm nearby here. Something I will try to get to place the 4 columns. Hey, Rama. Rama. Hey, Rama. Either watching the book. See, I correctly remember, you should see correctly all the 4 columns you have to see. See, now, I want to show the footing slab. This is the footing slab. Over that 4 columns are there. I place the 4 columns randomly. 1. See, 1 minute now. I will place it first, then show you. Somebody is helping me. Okay.
Not somebody. I am his brother.
He is my brother. younger brother, he is helping me. Nodi. 1, 2, 3, 4. ಸ್ವಲ್ಪ tilted. Can you see all the 4 columns? Can you randomly placed? Can you see all the 4 columns first? Can you see all the 4 columns? First. First tell me. Can you see all the 4 columns? ಅಥವಾ ಲಿಫ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ನಾವು ಅಯ್ಯೋ ನಾವು ಇದು ಫರ್ದರ್ ಲಿಫ್ಟ್ ಫರ್ದರ್ ಇನ್ನೊಂದು ನಾವು ಕ್ಯಾನ್ ಯು ಸಿ ಆಲ್ ದ 4 ಕಾಲಮ್ಸ್ ಈ ಕಡೆ ಹಿಂದೆ ಸಿ ನಾವು ಕ್ಯಾನ್ ಯು ಸಿ ಆಲ್ ದ 4 ಕಾಲಮ್ಸ್ ಇನ್ನೂ ಲಿಫ್ಟ್ ಅಪ್ಪ ಸಿ ಓಕೆ ನಾವು ಹಂಗೆ ನಿಮಿಷ ಸಿ he will go now. When I see front view, if I see here, I don't know from this side, this column is 1.3, that column is 1.225, it is slightly this side, this column is 1.35, this is 1.275, therefore, if I see this way, I am first seeing the back side column, 4th column. Then I am seeing first column. Then I am seeing column number 2. Then I am seeing column number 3. Load this way and couples are there. 1 minute. If I see from this side, then this is 1.225. This is 1.3. So I will see this column first. Then I will see this column. Here, this is 1.35 here, that is 1.275. I can see this column, then lastly, I can see this column. This column load is, I written 1200 kilograms, 120 tons. This column load, 1200 kilograms, 1000 kilograms, 900 kilograms, and 1200 kilograms. Clear now? Sufficient. Then see, he also got fully tired. So he helped me, my brother, he helped me for arranging it. ನೀನು ಯೂಟ್ಯೂಬ್ ಬರ್ತೀಗ ನೀನು ವಿಡಿಯೋ ನೋಡಿದ್ರೆ ನೀನು ಬರ್ತೀಗ ಸರಿ ಹೋಗುವಾಗ ಹುಷಾರು ಹೋಗೋದು ಏನಲ್ಲ ಹೋಗೋದಾಗುತ್ತೆ ಕ್ಲಿಯರ್ ಓಕೆ ನಾವು tell me. See, now see what I am doing. I will look this way. See, look this way. This is 1.225, 1.3. I can see column number 4 here. So I will call this as P4 column. P4. And then little further, I can see P3. From this side, this is 1.365. This is 1.275. From there, first you are seeing P2 here. You can see P2 here, and then little that side you can see P1. You can see P1. Now, this distance is P4 is 1.225 meter, and this distance is 1.3 meter. This column is 1.275 meter. P3, what happened here? P4, oh, this is P1, confusion. This is P1. Okay. That is P1, first column. That is P2, confusion. Okay. This is your P2, this is P3. This distance is 1.275. 275. This distance is 1.35 meter. P1 equal to 1200 kilonewton. P1 equal to P1 equal to this column 1.3 meter, 1100 kilonewton. This column is that side 1200 kilonewton. Then from here, first you are seeing P3 from that side. That is 900 kilonewton. 900 kilonewton. Other column is little further this side is 1000 kilonewton. 1000 kilonewton. Correct ಆಗಿದೆಯಲ್ಲ ನೋಡಿ. 2200 at 1.225. 1100 at 1.3. 1900 at 1.275. Then ಇನ್ನೊಂದು ಯಾವುದು? Other one is 1000 kN at 1.35. All lengthwise. Fully clear or not? Fast. Okay. Now I will put a mic on. ಸ್ವಲ್ಪ ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಮಾಡ್ತೀಯಾ? ಈಗ ವಾಲ್ಯೂಮ್ ಕಿನ್ನ ವಾಲ್ಯೂಮ್ ಸ್ವಲ್ಪ ಕಮ್ಮಿ. Now see, option 1 I am telling. This is common for both the option. I will do one thing now. See, this is how much distance? This is 6.5 meter. This is common for both the option. Okay, now come to option 1. Continue. What you do is tell me resultant column load. Bega. Resultant of all loads. That is P, single load P equal to P1 plus P2 plus P3 plus P4. Answer fast. P1 plus P2 plus P3 plus P4. Give answer fast. Don't waste time. See, whether you do option 1 or option 2, my guarantee, answer will tally. If answer does not tally, class will not be continued. If answer is not tallying, class will not be continued. 4200 kilonewton. Okay. Now we want to know where is resultant. Now I want line of action. Say at X bar from, see this point, it is AB line. See, this is AB line. Correct? This line, actually AB line, idu A comma D line this way. Referring to A comma D, that is referring from B comma C. Okay. X bar from left hand, you require. Use Varignone's theorem. Tell the answer. You write. That is, we don't know where is X bar. Randomly, the P is here equal to 4200 kilonewton at X bar from here. Now, apply Varignone's theorem. Algebraic sum of moments of the given force system about any point equal to moment of resultant about the same point. Take moment about this point. Answer. 1200 clockwise positive plus 1200 into 1.225 plus 1100 into 1.3 plus 1000 into from 6.5 subtract 1.35 plus next one 900 into from 6.5 subtract 1.275. All of them are clockwise. Still not over. Also all the moment this way. See here, this column, your column adu, fourth column has a moment of 60 kN meter here. See, a moment of clockwise of 60 kN meter. Which one? That is the fourth column. Correct? Yes, 60. And column 1 has anti-clockwise of 45 kilonewton meter. Only lengthwise. And column number P2. P2 column has moment of 50 this way. 50 this way. Anti-clockwise of 50 kilonewton meter. And column number, last column number 3. Column 3 has got ಹಿಂದೆ ಮುಂದೆ ಆಯ್ತಾ ಅಲ್ಲಲ್ಲ, ದಿಸ್ ಈಸ್ ಕಾಲಮ್ ನಂಬರ್ ಯಾರಿದು ಕಾಲಮ್ 3. ಓ ಸಾರಿ ಕನ್ಫ್ಯೂಷನ್. ಕಾಲಮ್ 3 ಹ್ಯಾಸ್ ಗಾಟ್ 50 ಹಿಯರ್ ನೋಡಿ. ಕಾಲಮ್ 3 ಹ್ಯಾಸ್ 50 ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಹಿಯರ್, ಇಲ್ಲಿದೆ. ಬೈ ಕಾಲಮ್ 3 is here, ಕಾಲಮ್ 3 ಇಲ್ಲಿ. ಕಾಲಮ್ 4 ಹ್ಯಾಸ್ ಗಾಟ್ ಕ್ಲಾಕ್ ವೈಸ್ ಆಫ್ 90, ಓನ್ಲಿ ಲೆಂತ್ ವೈಸ್ clockwise of 90 kN meter means now plus 60 minus 45 plus 90 minus 50 equal to resultant load 4200 into x bar. First tell me what is x bar. Answer first. Tell me what is x bar. First answer. Tell me what is x bar. Correct value I want. X bar. .049. No, I want little more number. 3.049. No, I told you whether I solve by option 1 or option 2, answer has to tally. So if you round off the number, answer will not tally. Slight variation will come. I told if any mistake happens, I will stop my teaching. I told that way. So nobody wants, none of you wants me to stop the teaching. So little more accuracy. 3.049404. 3.04 ಸುಳ್ಳು ಹೇಳಬಾರ್ದು. 3.049404. Okay. Now still because of this rounding off error, 10 paisa 20 paisa difference can come. That is okay. Why? Because rounding off error. Otherwise I should reset the question so that this comes round number. Okay, usually I do that way. Okay, no problem. Tell me, no problem or not? No problem or not? 3.049404. No problem? Okay, now start. Now this is resultant. See, now this sketch I cannot remove because I want refer. This I cannot remove. What I can remove? I can remove only this portion. Nothing else I can remove. So upper side I am removing. Remember, helplessly it will, when I do next widthwise, you have to calculate. I am not calculating. Widthwise you have to calculate. So I will remove the 6.5. It is giving trouble. 6.5 I want it now. Later I will write. I will remove all this one. Or see now answer. Therefore if you see lengthwise, see now, you mark the center line here. Tell the answer. How much distance from here and here to center of the footing? Length is 6 point, how much? Length is 6.5. How much each of them? Totally center of the footing. How much? Each of them, from each of them. Length totally 6.5. Each of them. ಇಟ್ಟೋದು ಬೇಕಾ? ನಾಳೆ ಬರಲಾ? 3.25 ಮೀಟರ್ ನೋಡಿ, ಇದು 3.25 ಮೀಟರ್. This also 3.25 meter. Now resultant load comes how much? 4200 is acting somewhere here. Tell why. Your P is 4200 is acting at x bar equal to 3.04. See, it came less than 3.25. Mark this side. If it comes more, mark that side. It is 3 point, or I'll do one thing. This is your x bar. Therefore this will become eccentricity. Tell me, what is the eccentricity? 3.25 minus x bar. If the load comes here, it is x bar minus 3.25. That much you can make out. If the load comes here, this will become E. Since the load is here, from center, eccentricity 3.25 minus 3.049404, 0.200596, 0.200596 meter. Or now you can replace it by this load you shift here, a load of 4200, and tell me a couple this way, anti-clock, this load from here. See, this complete system is equal to a single distance. From here, shift it here. It is equal to a load of 4200 and anti-clockwise couple of how much? 4200 into 0.200596. 200596. Answer 902.682. ಸುಳ್ಳು ಹೇಳಬಾರ್ದು. 902.682 anti-clockwise moment. Therefore, later remember your P is 4200, and I told you one lengthwise moment. If you remember, this moment was M2. This will be later M2. Clear or not? Because I told you this moment is M2, this is M1. So later your M2 becomes 902.682 anti-clockwise. So pressure calculation, this side positive, that side negative. Fully clear? Tell me fast. Fully clear or not? So fast. Fully clear? This is the final load and couple, load and lengthwise couple.